average demolition of a home can produce up to about 40 metric tons of waste.
You could densify the single detached neighborhoods, but not really change the form and character of these neighborhoods.
How do we design buildings that is truly good for both the people and the planet?
Hi, I'm Dagmar Timmer and you're watching The Sustainable Region. Today, we're here at the Richmond Olympic Oval where millions of people watched on TV as Olympic records were set. But the venue is award-winning in itself, receiving accolades for its innovative architecture and sustainable construction. We'll learn more about that a bit later in the program, but first let's check out a new way of looking at an old challenge in the construction industry. Using heavy machinery has been the standard way to demolish a house for decades. But now, experts believe there's a better way. It's called deconstruction. The young people around this table are being trained to take apart a house by hand so the materials can be sold and reused.
If you can just picture it coming apart, you'd start with the molding and the stuff on the shakes on the roof and everything, and then the 2x4s and the insulation, and just come down to the bottom when all you got is left is a slab.
It's hoped that learning how to tear down a house will help these young people rebuild their lives. They're in this training program because they've been identified as youth at risk.
I have an older brother who's in jail right now, and he's been there for about 6 years. And I just don't want to end up there because, you know, I see how it affected him and how it's affected my family, and I just want to stay out of trouble and just live my life.
Stephen has more reason than most to get his life back on track.
So that I know when I go onto a site what to do and what not to do and how to keep safe, and mainly because I'm having a kid, so I gotta get things under control.
Demolition is of particular concern in older communities like the city of Vancouver, where there are no vacant lots.
There's some really good benefits to deconstruction. So number one is it really reduces the amount of waste that goes to landfill. So our estimates say that, you know, the average demolition of a home can produce up to about 40 metric tons of waste, which is a huge amount of waste. So by using deconstruction, we can, you know, divert maybe about 85% of that.
Old wall plaster can be ground up and reused. Roof shingles can be melted down and combined with asphalt to surface roads. But it's the bones of the house, the timber, that's the most valuable commodity of all.
It's the best fir wood there is. People can't buy that anymore. That probably come from an 800-year-old tree.
Right now, the process of deconstruction can be more expensive because it's labor-intensive. 10 people can take 2 weeks to do a job that a two-man wrecking crew could do in 2 days. But it also creates relatively unskilled, entry-level job opportunities for people who might otherwise have trouble finding work.
When you go in for job interviews, they expect you to look all like clean cut and nice and stuff, and if you're not really living in like a steady place or a safe environment, it's really hard. It's really hard for you to go in and apply for a job.
These trainees are being paid to attend school. For most of them, it's the first time in their lives that they've had a decent income.
My family's never been financially secure. Almost all my friends that I know and their families, it's all the same, living paycheck to paycheck. I want to at least have financial security to the point where it's like big, phenomenal. Like that's my main goal.
The deconstruction training program takes place here at the Broadway Youth Resource Center. And this very building might provide a first job for many of these young trainees, as it's about to be torn down and rebuilt.
The young people in this program, we will connect with them and get them involved in deconstructing this building, so they will have get an opportunity to work on a significant project. And when we build the new building here, we will have young people involved in the construction, so that we're building a continuum of opportunities.
Opportunities that could change lives. And some would say already are. Welcome back to the Sustainable Region. Here at the Richmond Oval, the roof is not only beautiful, designed to look like the stylized First Nations wing of a heron, but the wooden wave design is also built entirely of trees killed by mountain pine beetles. That's 1 million board feet of wood that might otherwise have been wasted. Now, wood waste in the construction industry is a huge problem. It adds up to 250,000 tons in Metro Vancouver alone, and only a tiny fraction of this is incinerated and turned into energy. Metro Vancouver's solid waste management strategy seeks to ban wood waste from disposal completely by 2015. And already, there are companies figuring out how to turn that wood trash into cash.
The construction industry in Vancouver is booming right now, and that's good news for the economy, but it's very bad news for the environment. Construction waste in general, and wood waste in particular, is filling up our landfills.
The organic materials going to landfills, including wood materials, we like to target. In 2006, the Metro Vancouver Board adopted the Zero Waste Challenge. The region currently has a recycling rate of 52%. Canadian average is less than 30%. So we already recycle a lot in Metro Vancouver. But we're looking at going even beyond that.
The Mount Pleasant Civic Centre in Vancouver is a project being built using green construction methods, and that includes recycling any waste that's produced.
This project is a combination of rental suites and a civic center, and it's a LEED Gold project, which means it's a environmentally friendly building. It's absolutely a waste of material to not recycle what comes off of a construction site, especially given the volume. The types of waste we generate on a construction site are wood waste, metal, aggregates, drywall, just about every material you can think of. Most of it goes to landfill and other projects that aren't LEED projects. However, the city is now mandating increased levels of recycling and diversion from landfills. So that will mean that the construction industry will have to adapt.
Vanbot's Construction pays a premium to have bins of unsorted waste taken to a recycling facility. It's operated by Urban Recyclers, a company turning construction waste into money.
We have 2 processing plants in Metro Vancouver. We process approximately 200,000 tons of construction waste a year, 1,000 roll-off containers a week between our 2 plants. We recycle 80% of that per week, so that would be 800 of those containers if they were all the same weight that we save from going to landfill each and every week. Generally, most of the bins that we get in are what we call co-mingled, so they have wood and they have different construction waste from plastic to metals, these sorts of things in them. Right away we start sorting that stuff out. Then what happens is it goes across a picking line where we have anywhere between 7 and 9 pickers scrutinizing what's going through. I like to call these guys that work on the line the unsung heroes of the recycling world, because it's very labor intensive, it's very dirty work, and they work very, very hard and don't get a lot of credit for what they do, but they're really making a difference in our environment. They pull off all the recyclables that they can, which will be metals, copper wires, things of this nature. The wood that's left goes through what's called a hog mill, where it's ground down to a specific size depending on what it's going to be used for. There's no sense that this product should be going to landfill. There's economic opportunities to do something this waste. It's an exciting new area that we're very, very glad to be part of, because not only are you having an impact on your region and the lifestyles of people in Vancouver, but you can actually make a living doing it.
As our disposal costs increase, the costs for recycling should be lower. There should be an economic incentive. That lower cost for recycling should help drive this in the right direction.
We're leading the way in recycling. We've been doing this for years. There's endless possibilities, and there's a real bright future. We are making a difference, and everybody can make a difference if they come on board.
Welcome back to the Sustainable Region. Today we're at the Richmond Olympic Oval, and Greg Scott, Director of Development with the City of Richmond, is here to tell us more about this remarkable building. Greg, we've had a chance to learn some of the sustainability features, like the ceiling, but can you tell us some others?
Well, on the flip side of a ceiling is a roof. And with this 5-acre roof, if it was covered with a dark material, it would create a heat island effect, which would affect our neighbors. So we covered it with a white material, which sends that extra energy back into the atmosphere.
Now, my assumption would be a building this large and with an ice rink in it, heating would be a key consideration.
Well, especially an Olympic facility this large. You got a 400-meter track that requires a very large refrigeration plant that produces waste energy. So what we decided to do, that after the games, we make sure that that waste energy that was created by our little 2 sheets of ice balance the energy requirements for the building.
Super, and what a model for future Olympics. Thank you, Greg.
Thank you.
Our next story looks at a green building that is noteworthy for many reasons, starting with the plumbing. An extra set of pipes brings wastewater into the building on purpose. But it's all good because it's a research and education facility that focuses on wastewater and its potential as a resource.
In August 2010, Metro Vancouver began construction of the 1,500 square meter Annacis Centre for Research and Education, located beside the Annacis Island wastewater treatment plant. The $9 million facility will provide researchers, industry professionals, and the public with leading-edge, locally based research on managing and treating wastewater, promoting energy reduction, and mitigating environmental impacts. Not only will sustainable principles be taught at this facility, the building and surrounding landscaping put those ideas into action. As part of the provincial Wood First initiative, lumber from BC forestry companies is used wherever possible in the construction, including these locally manufactured Paralam roof beams. The landscaping will include plants native to our region, and the topsoil is a Metro Vancouver created product called Nutrifor, made on-site from a combination of local materials.
We're utilizing materials that had been brought in originally for preparing the site, so we're using the preload sand as a component in the biosolid soil mixture. And we're also using locally sourced wood products for creating that product as well. And the biosolids themselves come from the Annacis Island wastewater treatment plant, which is just on the other side of this fence here.
When the research center is completed, the key area of study will be integrated resource recovery, identifying the ways we can reuse the energy and resources found in wastewater. Some examples include using the heat energy from hot water that goes into the sewers to heat homes, generating electricity from the biogas created during water treatment, and collecting treated water for irrigation and other uses where it doesn't need to be fit for human consumption.
The way that these systems have evolved, they've been quite separate in people's mind. We get drinking water, that comes from the tap. When it leaves via your sink, it's into a completely different system. We've been thinking about that for decades as wastewater, cleaning it up, putting it back in the environment. The drinking water system comes from our mountain reservoirs. Over time, they will also need to be expanded. And an alternative to that is to look at ways to reclaim our water so it can be used for applications like toilet flushing, where in the future you don't need the highest quality water. And we can use this grey water, reclaimed water, in those applications.
We've got to play our role in pushing the envelope, in advancing the case for sustainability, discovering new techniques, and partnering with private sector and academic community to really achieve that leap forward into a sustainable future.
Welcome back to the Sustainable Region and our look at green construction practices. Here at the Olympic Oval, big is a necessity. After all, this building houses ice rinks, basketball courts, running tracks, and a host of other health and wellness facilities. But as we're about to find out, bigger isn't always better.
It's big. Enormous, in fact. You don't need to know the exact square footage to understand that this house is going to be huge.
What we've seen with these larger homes, they tend to be commodity issues. What a friend of mine affectionately calls to is interior design porn. You know, where you'll have homes that will have more bathrooms and bedrooms, homes that have extravagances, which really denote issues far more to do with social level, around class, around showmanship. And the home, in the way that it's been idolized, is moved past what's functional.
This Laneway home in Vancouver's Dunbar area is the antithesis of what's often referred to as a monster house. This house is positively petite, just 750 square feet, including the garage.
I think one of the main reasons for not building big is down to sustainability. We happen to believe that us trying to construct a very large house on our lot is not something that's conducive to the neighbourhood. We don't think that large 4,000 square foot houses make sense in an inner city area. It's a waste of space.
Smallworks is one of several companies competing in the market for small house design and construction. Laneway houses are the smallest examples, where it's important to maximize every square inch.
The main living area of the house is approximately 500 square feet, which is what is allowed by the city on this size of lot. So within that, we've actually constructed a two-storey building. On the lower floor, we have a combined living and kitchen area. We have a bathroom. And on the upper floor, we have a kind of loft-style bedroom and office work area. In addition to that, we have a garage. The garage is extra to the 500 square feet, and that is a mandatory part of the laneways, is to provide somewhere where the car can be parked.
The City of Vancouver has been approving laneway houses since 2009.
When we were talking about eco-density, everyone thought we were talking about high-rises everywhere. And I use terms like gentle density and hidden density and to show that you could do density in forms like laneway housing because they're tucked in behind off the lane and not visible from the street. You could densify the single detached neighborhoods, but not really substantially change the form and character of these neighborhoods.
Vancouver has already approved 400 of these tiny homes. Other municipalities with laneway infrastructures are also experimenting with this housing form, and for good reason. Small homes consume a much smaller amount of building materials. They contribute to social sustainability by making neighborhoods safer and more family-friendly, and they tend to be championed by builders with an environmental focus.
We're going to use our material effectively by building in a factory where we can efficiently put a building together, where we can focus on how we're going to be able to better deal with our waste, as opposed to how are we just going to get this house up quick and with a good profit margin.
So we've looked at the greenness of it from many different facets, but it really starts with more people using less land, and that has a demonstrable effect on our per capita greenhouse gas emissions.
Prefabricating the shell of the house off-site means it can be built very quickly. Just 2 days to put up the walls, floor, and ceiling. From start to finish, just 16 weeks.
It looks far better than we thought it was going to look. It's been a pleasure to watch how it's been built, and we're really pleased with the final result.
Annacis is using his laneway house as a rental property.
Well, we're going to be monitoring the results next after the first 150 units have been occupied for 6 months. I think we're going to see renters, aging parents downsizing into the laneway house so that their kids and grandkids can take the primary house. I think we're going to see caregivers. I think we're going to see young adults that have returned home but don't want to be in the primary house. It's a very adaptable housing form, and we expect its use will actually adapt and change over time.
It's always going to be a bit of a challenge when you try and do something new. We've had a history of building larger and larger, and here we are trying to build something more small and unique in the city, and we're ahead of the curve, and we recognize that, and one of our role is as much advocate as it is builder. We don't have to reinvent the wheel, but we can certainly improve it.
Welcome back to our look at sustainable building practices in the Lower Mainland. We're here at the Richmond Olympic Oval, where rainwater is collected on the roof and used to help flush the building's toilets. The rest ends up here in this pond, providing water for irrigation as well as an attractive place to sit down. Using the water that comes from the sky instead of relying on what comes out of our taps is one of the requirements of something called the Living Building Challenge. Its founder was in Vancouver recently, and he told us about how it works, as well as why he thought of the idea.
The new Visitors Centre at Van Dusen Botanical Gardens in Vancouver is exceptional in both its design and its construction. It's one of the projects in BC vying for certification through the Living Building Challenge.
The Living Building Challenge is the world's most stringent green building program. And the idea is to really push the design and building industry as far forward as possible and really ask them, how do we design buildings and infrastructure that is truly good for both the people and the planet.
The challenge asks that builders and architects achieve net zero energy and net zero water. In other words, that the project does not need energy or water to be purchased off-site.
Wouldn't it be great if our buildings generated all their own energy from the sun like the flower does? Wouldn't it be great if they only used the amount of water that fell on their rooftops and immediate surrounding area? If we could just be as smart as a flower, we'd be in so much better shape.
The flower analogy here is apt because this building's design is inspired by the petals of a flower with a bright center, or oculus as the designer calls it.
It's going to be bright yellow. It's going to stand out, and at night you'll see it from when you drive by. It'll be lit from inside. During the daytime, it's designed so that it captures the high sunlight and heats up fast, which then the heat rises and it forces ventilation of the building without any fans.
Electricity was a problem solved by sharing the building's ample stores of heat.
There's an existing restaurant on the site that has a very outdated heating system, so we put the most efficient solar hot water collectors. Then we share that heat with the neighboring building. In return, the restaurant gives us some electricity.
Water is collected on the building's green roof, seen here still under construction. It will be filtered and stored in 2 large underground cisterns for use as irrigation and to flush toilets. Black water from the bathrooms is also treated on site. The Living Building Challenge includes a list of toxic materials that may not be used. Some of these materials are standard items in the construction world.
One of the materials that we don't allow in the Living Building Challenge is PVC, polyvinyl chloride. When we see it everywhere in our buildings, it's used in pipe, it's used in wiring, it's used in siding. The unfortunate part is the manufacture of PVC produces dioxins, which are incredibly harmful to human health, and often those impacts happen in very poor communities where the factories are located.
Most of the wood you see here is reclaimed, like this bridge that's made of wood from an older structure on the site that was torn down. All the other materials had to be sourced from within a maximum radius based on weight. With a budget just shy of $22 million, it is the priciest example of a living building candidate to date. But the high price is due to the intricacies of the design, not its net zero energy infrastructure.
We don't realize that we're actually externalizing a lot of costs on society. And if we actually weren't degrading the environment, weren't actually hurting our economies in the long run by choosing cheap products made from thousands of miles away rather than creating jobs in our communities with local materials and local people, if we really thought it through, then building living buildings is actually the smartest economic choice you can make.
This project also meets LEED Platinum status, once thought to be the highest standard in green construction. Elevating the Visitors Centre to living building standards is a challenge that the Vancouver Park Board is committed to.
Park Board and City of Vancouver has unique opportunity and responsibility to actually push these boundaries of sustainable design. We do want to show with our example that it could be done, that it's not, impossible, and that people should really change the way they think about living and how they fit with nature.
We have about 100 registered projects in 8 countries. Out of those 100, there are 4 projects that have been through our very rigorous process, 3 of which are living buildings certified, and 1 of which came close.
Certification of living buildings is performance-based, and that means a building must be operational for a full year in order to be properly assessed. Such rigorous standards may be intimidating, and some buildings may not receive full certification. But the essence of the challenge is about changing the way people think, not just the way they build.
Pilot projects like this help people understand that this isn't crazy, that this is in fact really cool, that this can be beautiful and practical, and it opens minds. And then others are more brave. When someone else is the most brave, they can follow in their footsteps.
That's all we have time for on today's show, but we're already working on future episodes and we'd love to hear your ideas. So give us a shout. You can call us at 604-436-6794 or email us at sustainableregion@metrovancouver.org. For the Sustainable Region, I'm Dagmar Timmer. Thanks for watching and see you next time.